All right, so we're going to look at the matrix properties and operations. So we're going to look at how to classify a matrix by its dimension. We're going to look at how to add, subtract, multiply matrices, and also look at uh, the multiplication of a matrix by a scalar. So let's first look at some terminology, and that's very important as we talk about this particular section. So a matrix is classified by its dimension, that is, by the number of rows and columns it contains. For example, we have what's called a 2 by 3 matrix because it has 2 rows and 3 columns. So rows, you go up or down, and then columns, we read it left to right. So in general, a matrix with m rows and n columns has dimension of m by n. That's how we would read it. The number of rows is always given first. The number of rows is always given first. So we have what's called a square matrix, column matrix, and a row matrix. A square matrix is where the row and column, they are identical. Um, a a square matrix, let's clean that up here. A square matrix is a matrix where the row and column are identical. A row matrix is a matrix with just one row, and a column matrix is a matrix with just one column. So let's look at the first example. It says find the dimensions of each row. Identify any square, column, or row matrices. And then we'll come back to the other information about a matrix. So we have here, we have 6, 5, 3, 4, 5, and -1. So we want to see how many rows, how many columns does this matrix have? Well, we have 1, 2, 3. We have 3 rows. Remember, a row we would read going up and down. Okay, this would be a row. A column, we read it from left to right. So then how many columns would we have? We will have 2. So this would be a 3 by 2 matrix. 3 rows, 2 columns. Next example, we have here 3, -5, 0, 2. How many rows do you see here? 1, 2, 3, 4. And then our column, we only have 1. So this is a 4 by 1, and we would call this a column matrix. Next example, we have 1, 6, 5, -2, and 5. These are our elements here. What would be our row? What would be our column? we have 1 row and 5 columns. And this is what we would call a row matrix. Last example, we have -3, 6, 7, -4. How many rows? How many columns? We would call this, well, first of all, we have 2 rows and 2 columns, and we would call this a square matrix because the row and matrix have the same value, same number. Now, letter A here doesn't have a special name because there's nothing special to this other than to say it's a 3 by 2 matrix. So that is identifying the dimensions of a matrix. Let's look at the next portion of this of the notes here. We have 2 matrices are equal if they have the same dimension and if corresponding elements, position by position, are equal. Okay, so we have a 2 by 2 matrix here, 2, 1, 3, and -5. Then we have 1, 2, -5, 3, another 2 by 2 matrix. They are not equal because even we look at the elements in each matrix, position by position, they are not the same. This first row, first column, here we have a 2, then we have a 1. First row, second column, here we have a 1 and then we have a 2. So they're not equal. Okay. So, but if to make these equal, if the elements and its position were exactly the same, then they would be equal matrices, but they're not. Okay. So, the matrices are not equal even though they contain the same elements and are the same dimension because the corresponding elements differ. So that's why they're not equal. So now keep in position as keep in mind, excuse me, that we're looking at position by position. So we're going to look at this next example where it's asking us to find the value of each matrix. We have here our first matrix. We have 2, 5, 6, and then we have L, M, N equals to Z, Y, W, and we have 1, 8, -2. There we go. Okay, so we want to find the value of each variable. So how we're going to find that is look at each element in each matrix and look at the position that each element is in, and we're going to set those equal to each other. So first row, column 1 in each matrix, you have 2 is equal to Z. Then we have the first row, second column, we have 5 is equal to Y. First row, third column, we have 6 is equal to W. So can you finish the rest of these? Second row, second row, excuse me, first column, L is equal to 1. Then we have M is equal to 8. Second row, second column, and then second row, third column, N is equal to -2. So those would be the values. Those are the values of each variable. Now let's do another example. We have here Z, 4R, 8X, 6P, 2, 5. We have a 2 by 3 matrix plus our next matrix. We have -9, 8R, 3. We have 2, 5, 4. Here's another 2 by 3 equals 2, 2, 36, 27. We have 20, 7, and 120. So let's look at each row, each column, the entries, excuse me, the elements in each um, matrix, and we're going to match the corresponding positions. So first row, first column, we have here Z plus 9 is equal to 2. And then we'll solve those, but let's go ahead and set up everything else. First row, second column, we have 4R plus 8R is equal to 36. First row, third column, we have 8X plus 3 is equal to 27. All right, so let's look at the second row, first column. For each matrix, we have, I'm going to leave some space between these so we can go ahead and we'll be able to solve each equation. So we have here 6P plus 2 is equal to 20. Second row, second column, we have here 2 plus 5 equals to 7. And then second row, third column, we have 5 plus 4 is equal to, and let's change this right now while I'm looking at it. Make this 12A is equal to 12A. That's a typo on my part. All right, so let's go ahead and solve each of these. All right, so first equation, we subtract 9 to both sides. We have Z is equal to 11, not 11, but -7. And did I make an error here? Did you find the error? This should be Z minus 9 is equal to 2. I'm making mistakes right now, but that's okay. We'll clean it up. So then we're going to add 9, and then we do have Z is equal to 11. First row, second column, 4R plus 8R, we have 12R is equal to 36. Divide by 12, we have R is equal to 3. Second equation, we're going to subtract 3 to both sides. We have 8x is equal to 24. And then divide by 8, we have x is equal to 3. Second row, first column, we're going to subtract 2 to both sides. So we have 6p is equal to 18. Then divide by p, we have p is equal to 3. Second row, second column, 2 plus 5 is equal to 7. That is a true statement. It's 7. And then lastly, we have 5 plus 4 equals to 12a. Adding 5 and 4, we're going to divide by 12. And we have a is equal to 3/4. So as we put all of this together, we start off with a 2 by 3. We're going to end with a 2 by 3 matrix. So we have 11, 3, 3, another 3, 7, and 3/4. And that is our solution.